Once again, welcome to our Cyclic Geometry series. In today's lesson, we are going to cover the concept of cyclic quadrilateral. What is a quadrilateral? A quadrilateral is a polygon with 4 sides. A quadrilateral, this one is a 4-sided polygon. Then what is this cyclic quad? When do we now call it a cyclic quad? I'm assuming you can picture it in your mind to see when you talk about cyclic, it has to do with a cycle. So for a cyclic quad, we are inscribing a quadrilateral in a cycle. What is that? Which means that we are going to try to draw a quadrilateral such that all of its 4 vertices are on the circumference of the circle. Now this is your cyclic quadrilateral A, B, C, B. It's your cyclic quadrilateral because all of its vertices are on the circumference of the cycle. Now that is a cyclic quadrilateral. Now let's try to define our theorem on cyclic quadrilateral. Our first theorem, we are going to look at the opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral, which means it's this angle going together with this one. What is their relationship? The relationship between these two angles. Same applies to these two angles. We just want to establish the relationship between two angles of a cyclic quadrilateral. Now let's try to define the relationship. Saying the two, or rather let me say two opposite angles of a cyclic quadrilateral are supplementary. What does that mean? If you take a pair of opposite side angles of a cyclic quadrilateral, if we take a pair of the opposite angles of a cyclic quadrilateral, these ones, they are going to add up 280 degrees. So basically that is our theorem. Let's just prove this theorem quickly, but before we prove it, let's try to go and plot a Let's try to just go and plot a cyclic quadrilateral in GeoGebra and then view if this claim is actually true before we even go to prove it. Now we are here on GeoGebra. We need to draw a cycle. And then let's draw our cyclic quadrilateral. Now this is our cyclic quadrilateral. Now angle C, it's opposite to angle E. So if we add those two angles, we are expecting to get an 80 degrees from the theorem. Let's try to measure these angles here. This is 108.43 plus 71.57. It actually gives us 180 degrees. How about these two? P and V, they are opposite angles, right? Yes, these ones are opposite angles. Now angle B, it's 98.11, and then angle D, it's 81.89. If you add those two, still you are getting 180 degrees. Now let's move on to how can we prove this theorem, just to prove it. So to prove this theorem, we are just going to draw a cycle. Let's draw our cycle here. Just a quick one. And then there is our center there. And then draw the cyclic quadrilateral. All the vertices lie on the circumference of the cycle, like that. And so to draw, we are going to construct this line to the center, from the center to that one there. Now let's call this angle X. This one angle Y. We want to find the sum of those two. Now let's use our theorem. Angle at the center is twice the angle on the circumference. This one is the angle on the center. This one here, it's your angle at the circumference. So this is twice the angle at the circumference, so it's 2x. Same applies to the one on top here. It's this angle here. Angle at the center, it's supposed to be twice this one. So here we are having what? A 2y. Now let's go quickly. If you add 2y and 2x, what do you get? It's actually angles around a point. and then it's actually a revolution, which should give us 360. And then if you divide everywhere by 2, you're getting y plus x is equals to 180, which indeed shows us that the opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. Let's move straight to examples. See here, let's move straight to examples. First example, you are required to find the values of x and y. Let's check. Opposite angles, this is opposite to that. So what do we know? Opposite angles of a cyclic quad, they add up to 180. 95 plus its opposite to y, so plus y, they should give us 180 degrees. Then from there, just subtract 95 from both sides of the equation, and then the 95 is going to be cancelled out here, and then you are left with your y is equals to 180 minus 95 is actually 75 degrees. Now let's check the other one. This 70 degrees is opposite to x, so opposite angles of a cyclic quad add up to 180. 70 plus its opposite to x, so plus x should give us 180. Opposite angles of a cyclic quadrilateral add up to 180 degrees. Then from there, let's subtract 7 naught on both sides. Then your x is equals to 180 minus 70, it's 110 degrees. Is to just cancel out. And the next example, this one, it's a tricky question. Don't just overlook. It says use both angle at the center is twice the angle on the circumference, and opposite angles of a cyclic quad theorems. You must use both of them to find the value of x and y. Now let's check x and y. These are opposite, so the sum of these two should give us 180 degrees. But they are both unknown, so it's not helping us yet. So let's try the other theorem, which we were told to use. Angle at the center, 30 degrees. And then the angle at the circumference corresponding to the 130, it's x. It's 130 and x. So half of 130 should give you x. What does this theorem say? Angle at the center is equals to twice, 2 times the angle on the circumference. Then if you divide both sides by 2, you are going to get that your x is equals to 65 degrees. Then from there, opposite angles of a cyclic quadrilateral, those two, x plus y is equals to 180, add out to 180 degrees. Then we already know what x is. X is 65 plus y is equals to 180 degrees. Then subtracting 65 from both sides, minus 65 minus 65. Then what happens? The 65 cancels this one, then you are left with y on the left. Then this is equals to 115 degrees. Then we have used both the theorems. Next example, solve for x. Now let's check this angle. It's opposite to this one, so they must give us the 180 if we sum them up. But we also need to know this portion here. How do we find that portion? Let's try to extract this triangle here. Let's try to extract that triangle. It's something like this. So this is equals to this, and then this is equals to this one here. We'll talk about this theorem later, whereby a line drawn from the center and then it's perpendicular to a chord bisects the chord. Since they've told us that this line, which is from the center to the chord, they've just told us it's perpendicular, so it must actually bisect this one, which in turn gives us two congruent triangles. These two are congruent triangles, so this and this are congruent triangles, which simply tells us that here we have a 72 degrees and then this side we have a 72 degrees. Then now we need to find the base angles of an isosceles triangle. Let's call them x. We do have x already. Let's call them y, so that our y plus 72 plus 72 should give us 180 degrees, sum of interior angles in a triangle. Then from there I'm having your 2y plus 72 plus 72, it's 144, is equals to 180 degrees. Then if you subtract 144 from both sides of the equation, subtract 144, we are getting that 2y is equals to 36. And then if you, to make y the subject, you just divide by 2 on both sides of the equation. We need to isolate our y. So to isolate the y, we need to divide by 2. And then after dividing by 2, you will notice that this 2 is going to cancel that one there. Then you have your y is equals to 18 degrees, which means now here we have 18 degrees. And now we have the two opposite angles of our cyclic quadrilateral. these are the two opposite angles of our cyclic quadrilateral. What do we know about the opposite angles of a cyclic quadrilateral? Is that they add up to 180 degrees. So we have your 2x plus 4 plus 20 plus 18. This should give us 180 degrees. Take note of this. This is one angle, and this one is the other angle that is down there. So the opposite angles of a cyclic quadrilateral, they should give us 180 degrees. That is, they are supplementary. Now let's solve this linear equation here. Let me rewrite it without now let's check like terms here. What are like terms? Two terms are called like terms if it's a number attached to a variable raised to the same power. For example, if you have 2xy and 7xy, we have two numbers here. We have two numbers. We have this and this one. They are attached to the same variables x, y, and they are both raised to the same power, which is power 1. So we call those two like terms. But for this one, 3x and 4, they are not like terms. Because why are these two not like? This one has an x, this one does not have an x. And then if this one was having an x, but the x here it's to the power, they are still not the same or the like terms, because they are now, they do have the same, but the variables they are having that is not raised to the same, so they are not like terms. So for this case, our like terms, it's 4, 20 and 18. So if you add 4 plus 20 plus 18, what do we get? We are getting 42. So here you have your 2x plus 42 is equals to 180 degrees. Then from there, subtract 42 on both sides of the equation. Subtract 42. Then what it will happen, the 42s are going to be cancelled out, and then you will be left with 2x being equals to 180 minus 42, it's 138. Then divide both sides by 2 to isolate the x. This is over 2. This is over 2. Then on your left, the 2's are going to be cancelled out, and you will be left with only x, which is equals to 138 over 2. It's 63. (138 over 2). It's not 63. It's supposed to be 63. 138 over 2, it's 69 degrees, which tells us that the value of x is 69. Let's check it. If we put 69 there, you have your 2 times 69 plus 4. 2 times 69, it's 138 plus 4. This is giving me 142. And then plus the 48, the 38 there. This is giving us the 108, which means it's a correct solution. So the value of x for this one is 69 degrees. Thank you for staying tuned in this lesson. On our next lesson, we are going to explore what could be the relationship between an exterior angle of a cyclic quad together with the interior angles. Thank you.